Now we're going to take a look at some derivatives involving the natural log function, where we're going to want to take advantage of the properties of logarithms before we determine the derivative. Notice in its current form, u would be a product involving a square root, therefore determining u prime for the chain rule would be a little bit challenging. But because we have the natural log of x times the square root of the quantity x squared plus 1, we can use the product property of logarithms to write this as a sum of two natural logs. We would have f of x equals natural log x plus natural log, and I'm going to write this square root as a rational exponent, so we'll have the quantity x squared plus 1 to the 1/2 power. And now before we determine the derivative, we can apply the power property of logarithms given here, so we can take the exponent of 1/2 and move it to the front and multiply it by the natural log. So we'd have f of x equals natural log x plus 1/2 natural log of x squared plus 1. Now determining the derivative of the function in this form is going to be much more manageable. So we'll have f prime of x equals the derivative of natural log x would be 1 divided by x plus 1/2 times the derivative of natural log x squared plus 1. This requires the chain rule. So using our formula here, we would have u equals x squared plus 1. So the derivative would be 1 over u times u prime, or 1 over x squared plus 1 times u prime, which would be 2x. We'll put 2x over 1. So this is our derivative function. Let's simplify. Here we have a 2 over 2, which simplifies to 1. So we have f prime of x equals 1 over x plus x all over x squared plus 1. So this is our derivative function, but a lot of times you'll be expected to add these two fractions. Notice our common denominator would be x times x squared plus 1. So we'll multiply this first fraction by x squared plus 1 over x squared plus 1. We'll multiply the second fraction by x over x. Notice how we do have a common denominator. So f prime of x is going to be equal to the sum of these two fractions, where the denominator is x times the quantity x squared plus 1, and the numerator would be x squared plus 1 plus, this would be x squared. So our numerator would be 2x squared plus 1, which doesn't factor, and our denominator would be x times the quantity x squared plus 1. So here's our derivative function. We'll take a look at another example where we want to apply the properties of logarithms to the initial function before determining the derivative in the next video.